Okay, my name is Reginald Seay, and today we'll be going over a fairly simple convolution problem. Alright, and the convolution problem that we have states what is y of t, which is equal to f of t convolved with g of t. And then for our f of t, we have 2 times gamma of t minus gamma of t minus 1, and g of t, which is equal to gamma of t minus gamma of t minus 2, all divided by 2. And for this one that we have, we'll have 5 different regions. So there will be 5 regions of integration in which we will do to solve the convolution of f of t convolved with g of t. Okay, so let's begin. Alright, so we have our region 1. For region 1, we have t less than 0, and t less than 0 is f of t convolved with rg of t. And this will be equal to 0t times f of lambda times g of t minus lambda. And this is d by d lambda. So d lambda is what we're doing the integral of over. And then we can say that that is the integral from 0 to t of 0. And this will be equal to 0. Okay, so region 1 was pretty simple, but it gets more complex from there. So now we do our region 2. Now region 2 is 0 less than t less than 1. And then we say f convolved with g of t. And we write again t, the integral of 0 to t of g of lambda times g of t minus lambda d lambda. Then we can say this is equal to 0, for the integral from 0 to t of 2 times 1/2 times d lambda, which is equal to t. Okay, so now that we have that, we can do region number 3. Alright, for our region 3, we have 1 less than t less than 2. And we're writing again f of t convolved with g of t is equal to 0 to t, and this is for f of lambda times g of t minus lambda d lambda. And it's just a good practice to write down 0 to t f lambda times g of t minus lambda, because this is our convolution formula. So we write that down every time we do our convolution. Okay, so our intervals for this one will change to become from 0 to 1 of, and this is 2 times 0 to 1 of 2 times 1/2 over d theta. Oops. I'll write that over again for you. So it is, we're doing our region 3, So region 3, from 1 to t, 1 less than t, less than 2, and this will be our f of t convolved with g of t. And this is equal to the integral from 0 to t f lambda of g of t minus lambda d lambda. And then, like I said before, this is equal to 0 to 1 for our integrals of 2 times 1/2 d lambda, which is equal to 1. Okay, and that's it for our region 3. Now we can move on to our region 4. And for region 4, we have 2 less than t less than 3. Okay, just like before, guess what? We write f of t convolved with g of t is equal to the integral from 0 to t of f of lambda times g of t minus lambda d lambda. Yes, it may be painstaking, but this is great practice to help you to do the convolution, to help you remember what the convolution formula is. So we will still write that every time. And this will be from t minus 2 to 1. And this is times 2 from t, this is our integral from t minus 2 to 1. And it's from t minus 2 to 1 because t minus 2 is the leftmost side of where the parts intersect. So we have the g of t that is shifting with respect to the f of t. So we have some g of t graph which is shifting, and then our f of t is remaining still. So they've intersected now, and part of the g of t is intersecting the f of t, and the other half is still outside. So we still have the leftmost, which is not touching, will be our t minus 2, and the rightmost will be our 1. And then we do 2 times 1/2 d theta, which is equal to 3 minus 2. Okay, so finally we made it to the end. Finally, we're at our region 5. Finally, yes, we made it. We made it to region 5. Woo! Okay, so for our region 5, we can say it's 3 less than t. 3 less than t, which is f of t convolved with g of t, which is equal to the integral from 0 to t of f of lambda times g of t minus lambda d lambda. And then this one looks like one we did before. You guessed it. It looks like the first one that we did. So we have our interval from 0 to t of 0, which is equal to 0. And we're done. Woo! We're done with convolution. And then, so a quick recap. So for region 1, we have t less than 0. And then for the region 5, we have 3 less than t. So both of these are the same. So this is from where the graph comes, you have the g of t, which comes closer to the f of t. And then it goes, and the region 2 and 3 shows where it intersects, and it's partially intersected and partially not intersected, and then fully intersected. And then our region 5 will show where it has finally intersected all the way through. So you have some shape that comes in, it intersects part of it intersects, all of it intersects, then you have a second half that's still intersecting, the right half that's out, and then you have the whole part that's out. So in a nutshell, that's what you have for this convolution. And that's basically what convolution is. You just have some shape that's intersecting another shape, or some graph that's intersecting another graph, and it goes through, and this is just representation for all time in which it goes through. So you have some stationary graph, then you have some moving graph, and it slides through for all of time. All of time it goes through. And then now we can write our final convolution. So like just another way to write the convolution, just to sum up everything that we've done. We can say that let me erase that real quick and erase this T. We say that 0, because that's what the value was for the first one, is from the range of t less than 0. And then we can say that t is the value that we got from the region 0 less than t less than 1. And then we can also say that for that 1 was the value that we got for our region, just 1 less than t less than 2. And then for region 4, we say 3 minus t, because 3 minus t is the value that we got. Ooh, that's a nasty 3 minus t. Sorry about that, my handwriting just went crazy right there. Let's erase this bracket too. Alright, so rewriting that is 3 minus t. There we go, 3 minus t. And this is our region 4. And that is from 2 less than t less than 3. And then 0, which is where it exits. And we have 3 less than t. Alright, and there's our convolution. I hope this has helped you out in any way possible, and thank you for your time. My name has been Reginald Seay. I hope y'all have great success with convolution. Alright, good luck.